Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the concurrence from you guys. The quality of audio and video, is it perfect or not? If it is perfect, just write perfect over the chat box. And the agenda behind today's video is to cover the concept of probability distribution as well as density, and we'll be talking about the random process. And I know this is the topic where most of the students do not know even a single basis behind this. They just mug up few of the formula and they go with those formulas into the examination, although they might be able to solve few number of problems, but still I know most of us do not know exactly why the concept of random variable, random process all have come together, okay, perfect. See, as I have said, the agenda behind today's video is to cover the concept of random variable as well as random process as well as probability distribution and density. If you really want to know the concept of probability distribution and density, you had to go through the concept of statistics. So if you have a fair idea about these statistics, you would be able to appreciate the concept of random variable as well as random process in the great detail. Is that part clear? So put the heading everyone. The heading is gonna be statistics. Yes, once the statistics is over, definitely we'll move it into the probability distribution as well as density. So within these statistics, we follow the two different process. As far as the statistics is concerned, we follow the two different process. Write down. In statistics, we follow the two process. The first process is gonna be collection of data. And similarly, the second process is gonna be analysis of data. Yes. See, try to understand why the collection of data as well as the analysis of data is so important. Just take few number of examples, you will get to know why the collection as well as the analysis of the data is very important. If you take an example of Reliance Jio, if they have come to the market and if they wanted to launch few of their plan, what they would have done? First, they would have collected tremendous amount of data which are the users from Airtel or Idea. Once they will collect all of the data, they will sit over the data and they will analyze and they will conclude something. And after the conclusion is taken out, now they will design their own plan. Yes. Similarly, if I take another example, if you are the captain of Indian cricket team and you had to finalize your top 11 or playing 11, maybe you are touring in Australia. So how will you select the top or last 11 playing 11? You will be collecting all of the data from each and individual cricketer and you will see how about their performance or how about their average performance in Australia, and according to that merit you are going to select that player in final 11. So whenever you come into the situation when you had to take certain decision, what you do? First you collect the data, thereafter you analyze the data and then you conclude what would be your final decision. Like, if somebody is borrowing with you, so first you'll think whether I should give him borrow or not, whether I should give him money or not. What you'll do? You'll see his past track record and you'll try to visualize whether my final decision would be yes or no. So whenever we talk about the statistics, we used to have the two process. First we'll have the collection of data, and similarly once the data has been collected, out of chunk amount of data, see, for the time being, if you collect the data, how the Sachin has performed in last 200 matches. So you will have the 200 numbers. Might be in first match he could score 36, in second match he could score 0, in third match he could score 100. See what is happening? Chunk amount of data you have got it in front of you. But what you will do at last? See, approaching the all 100 data is not that easy. So what you will do? You will just extract one data out and you will try to understand or you will try to analyze how the almost all data has been centered along this data. Like the performance of the cricketers used to be judged by the two performance parameters. May I know what are those? Average, what about per match they run, and similarly their strike rate. But anyways, what we are going to do, first we'll collect all of the previous data of that batsman or bowler, and at last we'll analyze something. At last we'll analyze something. Is that part clear? We'll analyze something. So let me go ahead. First focus over the collection of data. Let's first focus on collection of data. Yes. See, the data can be collected in two different forms. The first is gonna be grouped form and second is gonna be ungrouped form. So the collected data I would be bifurcating in the two parts. The first part is gonna be ungrouped data. Where we will be having a bare datas, or I can say datas without any class and frequency. No, you will not have any class and frequency while you are collecting the data in the format of ungrouped data. And similarly, the second kind is gonna be grouped data. And here you will be having the data in form of class as well as its corresponding frequency, as well as in terms of its corresponding frequency. Yes, both of the type of data collection have got their own advantages as well as drawbacks. I will not be going into that detail because my basic focus or basic intention is to discuss the concept of probability density as well as distribution. But still, while taking few number of example, I will let you know what's their advantages, what's their drawbacks. Let me take few number of examples. If I have taken example, run is scored by Sachin in past 5 matches. Yes. So I have taken an example, like in first match he could score 90 runs, in second he scored 60, in third match he scored duck, then maybe 1, and then maybe 120. So just I wanted to know from each one of you which type of data collection it is, whether it's an ungrouped data, whether it's a group data. See, we have got the bare data. That means we did not have certain range of the data, and for the certain range we did not have the frequency or repetition, and hence this data is simply gonna be ungrouped data. It's gonna be simply ungrouped data. Agreed what I'm saying? So let me go into the next page. Similarly, let me take another example. I am going to take example number 2. I am going to take the example number 2. Now let's take marks scored by a student, maybe Asu, in past 4 examination. And let's take the data are being given as in first examination out of 100, let's take he scored the complete 100 marks. Maybe in second he scored 90 marks. And similarly, let's take he scored maybe 50 marks in the third examination. Yes. So may I know which type of data it is? It's again ungrouped data. It's again ungrouped data. So probably you might be visualizing this concept very well, that yes, it's a type of ungrouped data. Why it's ungrouped data? Because as such there is no class and there is corresponding no frequency. No frequency. Is that part clear? So you can see very well, it's again a type of ungrouped data. So may I know the quality of video and audio? Is it perfect? No? Is it perfect or not? Okay, okay, perfect. Just I wanted to know the quality of audio and video is perfect, no? So please tell me over the live chat, the quality of audio and video, is it perfect or not? Perfect, okay, 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 then it's fine. Now, let me take another example. Let me take another example. I have taken example of example number 3. Example number 3. Now, in case of example number 3, what I have done, I have taken the history of Sachin. History of Sachin in past 15 matches. In past 15 matches. And what I did, I have distributed their runs. I have distributed their runs in form of certain range. Let's take, it's a range of runs, and in corresponding to the runs, I have seen how many times that particular run got repeated, and here I can say this as frequency. Now I have taken situation like 0 to 20, then not 0 to 20, okay, 20 to 40, 20 to 40, 40 to 60, and 60 to 80 runs it is. 60 to 80 runs it is. And let's take the frequencies were 5, 3 and 2. 3 and 2. Yes. And if you want, you can calculate the cumulative frequency also, because in future, once we will be discussing the concept of probability distribution as well as density, definitely this thing becomes very important. Yes. So here, the 5 would be 5. 5 plus 5 would become 10. 10 plus 3 would become 13, and 13 plus 2 would become 15, which is the total number of matches it is. Is that part clear what I am saying? Which is the total number of matches it is. Agreed till this point? No. That's the basic difference. If I would like to ask which type of the data collection it is, so definitely it's gonna be a grouped data. Why? Because you have got a certain class. In first class, you have concluded all of the data which is in between 0 to 20, including 0 and excluding 20. Whenever you have a proper class, keep in mind the first data gets included, the second data gets excluded. And similarly, it will happen with this as well as this, including and excluding. May I know what the frequency indicates? What's the frequency indicates? Frequency indicates the Sachin got out in between 0 to 20 5 number of times. Similarly, 20 to 45 number of times, 40 to 63 number of times, 60 to 82 number of times. May I know what the cumulative frequency indicates? Sachin got out 5 number of times lesser than 20 runs. Now. If you talk about 10, this 10 have come by adding 5 as well as 5. That means when he scored the run in between 0 to 20 and similarly in between 20 to 40. So may I know what is 10? 10 is the number of times Sachin is scored lesser than 40. Similarly, what's the 13? 13 is nothing but the number of times the Sachin has scored lesser than 16. And similarly, what's the 15 over here? It's nothing but the number of times the Sachin has scored lesser than 80. So in future, I would be using the cumulative frequency again and again once I'll be discussing about, once you'll be discussing about the probability density function. In next, you had to discuss about the cumulative probability density function. There, this concept would be repeatedly used. Could you understand what I am saying? So let me do one thing. Yes. So what I am going to do, so far you could have figured it out. The example number 1, example number 2 was the case of ungrouped data. Ungrouped data. And similarly, example 3 was the case of grouped data. Grouped data. Grouped data. Yes. May I know when the ungrouped data is more important, or what's the advantage with the ungrouped data, and similarly what's the advantage with the grouped data? See, in case of ungrouped data, accuracy would be highest. Highest accuracy. Accuracy. Where the accuracy is lesser in case of grouped data. Grouped data. But once you'll see, if you have plenty amount of number which you have collected, it would be much complex to deal with, because if you have huge chunk of data, dealing that data with the help of ungrouped data becomes very difficult. And whereas if you will make a certain class, and within that class, if you are marking down how many times that class has been repeated, definitely it becomes much simple. It becomes much simple. Now I would say why the grouped data are inaccurate or the accuracy is least. See, try to understand what I have shown. 0 to 20 runs he has scored maybe 5 times. Exactly you cannot say 5 times how much run he has scored. You do not know, maybe all of the 5 times he could have scored only 0, 0, 0, 0 and 0. Maybe all of the 5 times he could have scored 20, 20, 20 and 20. Maybe in all of the 5 number of times he could have scored 10, 10, 10, 10, 10. See, when we take average or mean of the closed group data, what we do? Could you able to recall how we do? We take x of I. In x of I, what we do? We take the average of the class. We add the first class and second class limit and we add them together and we divide with 2. So may I know what would be the average of the first class? That would be 0 plus 10, that's a 10 divided by f2, that's a 5. And we are assuming, 0 plus 20 divided by f2, that's a 10, and now we are assuming that 10 have got repeated 5 number of times. That means in first class the Sachin have scored how much? 10 into 5, that's a 50. But there could be a mistake. There could be a situation that the Sachin could have got 0, 0, 0, 0 all of the 5 times. That means in first class, which was your assumption that he could score 50 runs. No, he could just score 0 runs. Similarly, there could be another situation. What is that? He could have scored 20, 20 all of the 5 times. That means in first class he scored 100 runs, whereas we have just considered 50 runs. We have just considered 50 runs. Is that part clear? So that is what I am saying. With the ungrouped data, the complexity is the problem, but in case of grouped data, simplicity is the advantage. Simplicity is the advantage. Yes. Now, once you have collected the data, now it comes the analysis part. Analysis part. That means the collected data has to be analyzed further. And we'll try to conclude few of the important outcome after the analysis. Within the analysis, we would be focusing over the two different factors. First is gonna be central tendency, and the second is gonna be dispersion. There are several tools which analyze the central tendency of the collected data, which starts from mean, median, mode. Similarly, as far as the dispersion is concerned, which is being used using range, standard deviation, variance, quartile deviation, there are several tools which are used for the calculation of dispersion. But as far as my GATE syllabus is concerned, the question repeatedly comes from only two tools. Once we talk about the central tendency, basically we had to be focused on median, mode I am not going to focus, at least on crash course. And as far as the weightage of median and mode is concerned, very rarely question do come. Yes. And now we shall be discussing about the dispersion, and within the dispersion we would be talking about only one thing, and that's nothing but the standard deviation or the square of the standard deviation, which is called as variance. Yes. Could you understand what I am saying? My understanding is like. First I have collected the data and now I am analyzing the data. Now the first thing comes in your mind, sir, why you are collecting the data? Just to get certain conclusion. That's fine, sir. How will you collect the data? The collection could be in two different ways. Ungrouped data means the bare data, like how much Sachin have scored in the last 5 matches, just bare data. Now the second kind could be the group data. In group data you will have a lower limit and upper limit. It could be in terms of runs, it could be in terms of subject marks, it could be in terms of the wicket taken. And now you will be seeing the how many times that class got repeated in terms of frequency. Not only that, if the cumulative frequency has been taken near to cumulative frequency, that talks something great. That talks about how many times the data got repeated lesser than equals to of the highest limit of that class. That is also okay, sir. That is also okay. Keep in mind those all things are going to be in great use once we will be discussing about the probability distribution as well as density. Sir, okay, you have collected the data. What else? What next? What next you would be doing? Now I would be analyzing the data. Just I will say one thing. How the Rohit Sharma is getting selected in Indian team again and again. See, maybe in past 2 matches he could not perform well, but still he is getting selected. Why? Because once you will collect his all data and once you will take an average, once you will take its average, you will get to know his average may be reaching towards a 50. That means on average in per match he scores 50 runs. That's a different story together. In the last 2 matches he could not perform. What does it mean of it? That means out of chunk of data you are going to analyze, you are going to conclude something. The first conclusion is central tendency. That means on average in each match how much marks or how much runs or how much wickets a person is being allocated. And that would be mean. Yes, that would be mean. In future the mean is also called average, and once you will go into the concept of probability distribution and density, this would be called as a expectation. Yes, expectation. Similarly, now the next thing comes. Okay, sir, you got to know about the mean value and it looks okay to calculate the mean. Then why the variance or standard deviation was calculated? May I know which information is contained by the variance or standard deviation? Yes, now here comes a situation. Everybody should have the clear cut focus over the next example. Like I have had a player 1, I have had a player 1, I have had a player 2, I have had a player 2. Yes, let's take the player 1 have scored runs as 49, 50 and 51 in last 3 matches. Could you agree? And whereas the player 2 scored 100, 50 and 0 in last 3 matches. May I know what would be their averages? Once we will go into the concept of average, you will get to know. First we will add them together. The addition would become 49 plus 50 plus 51. That would lead 150 divided by 3. That would be 50. Yes. And here also if you will say, its average is going to be 100 plus 50 plus 0 divided by 3. It's a 50. So as far as the central tendency is concerned, mean is concerned, for both of the collected data, the mean are very same. But still you guys might be finding, sir, still there is something fishy which is getting involved between the performance of the player 1 and performance of the player 2. What is it? Keep in mind their consistency. May I know which data is more consistent? How will you define consistency? Anyways, once we'll discuss about the dispersion, we'll get to know about it. You can very well see here the consistency is high, here the consistency is less. Although both have got the same mean value. That is what I am saying. If we talk about on average performance, go ahead with the mean, average or expectation. Once we are talking about how the data are dispersed, how the data has been distributed, like here the data distribution is too consistent and here data distribution is very less consistent. And if I take another player, let's take the player number 3. If in first match he got 50, in second also 50, in third also 50. So you can see here also average is 50, here also average is 50, here also average is 50, and you can say he is the most consistent player. He is the most consistent player. Yes. So whenever we talk about the central data, average data, I would be going ahead with the mean, average or expectation. And whenever we talk about how the data are varying, definitely we need to go with the dispersion. If you would be able to recall, the average of Rahul Dravid as well as Sehwag was same. Probably you guys are from new era, you may not be able to judge how their performance was. If I compare the performance of Sehwag and Rahul Dravid, once you'll talk about their average was almost same. I'm just taking an example. Maybe in each match on average they score 50 runs, but once you'll talk about their variance, the variance was too large. Maybe you can take the variance value with the Sehwag was 12, and in case of Rahul Dravid maybe it was 3. See, from the variance what we got to know, higher the variance, higher the inconsistency. Sehwag, sometime he'll play for 200, in next two matches he'll go for 0-0. Whereas Rahul Dravid, he was so consistent. In first match he'll play for 45, second match he'll play for 55, third match he'll play for 60, 40, still he was getting the same average. So end of the day, what is happening over here, higher the variance, higher the inconsistency. So till this point, each and everything is clear or not, just write clear over the chat box, and then we shall move forward with pure important concepts. Yes, could you understand central tendency, what it talks? It talks about on average in individual trial, and similarly dispersion, what it talks, how the individual data are distributed. I want the comment over the chat box. Tell me. The quality of audio and video is perfect, no? Because I am not getting any comment over the live chat. So that is what I am worrying, whether everything is working fine from your side or not. I want the comment over the chat box. Tell me, everything is okay, no? Tell me. Okay. Yes, till this point each and everything must be clear to all of us. Now let me go ahead and let me discuss a bit about all of these two data. The first data, or the first parameter, which we call it mean. Mean is also called average. And average or mean would be called as an expectation in case of probability, distribution and density. Sometime even it's also been referred by mean as well as average. Yes, could you understand what I'm saying? Mean as well as average. So first data which I have taken in my consideration, let's take that data is nothing but ungrouped data. That means you have n number of bare data for the time being. Let's take the bare data are x1, x2, goes till xn. And if I wanted to get its average, keep in mind the average is also written as x bar. May I know what would be the average of it? It's simply going to be x1 plus x2 goes till xn and would get divided by n, would get divided by of n. Or if you want, you can write this in the form of discrete sum, where the xk goes from 1 till n divided by of n, divided by of n. What are the x1, x2, x3 till xn? They are bare datas. And similarly, what is the n over there? It's the number of observations, and x bar is nothing but the average of the given observation. Given observation. Everybody should write each and everything, because end of the day you guys are going to enjoy the class of probability, distribution and density. Is that part clear? So here it's the observation. It's the observation. Yes. And now they got added, and n is number of observations. Number of observations. Number of observations. Yes. Now if I take another scenario, or you can take an example, if you have the datas like, if you have a datas like maybe 1, 2, 3, 4, 5. 5 datas you have, and you wanted to get the average of it. So average is simply gonna be, you will add them together, 1 plus 2, 1 plus 2 plus 3 plus 4 plus 5 divided by a 5. Let's take 1, 2, 3, 4, 5 are the wicket taken by, wicket taken by any bowler. So that means in past 5 matches, a player have taken 1 wicket in first match, third in third, in fourth match he got it 4 wickets, and similarly in fifth match he got it 5 wickets. May I know on average how much value you are getting? On average how much value you are getting? You had to just add them together, 1 plus 2 plus 3 plus 4 plus 5, 1, 2, 3, 4, 5 divided by a 5 you had to do. What does it mean of it? That means the bowler have taken 3 wickets on average per match. Per match. Yes, that the average indicates. Yes. Now we'll try to understand. We'll take another scenario, and let's take a grouped data. May I know what would be the formula for the grouped data? See, the formula from the ungrouped data and grouped data are quite same. There is no such difference. See, in grouped data, what you will have? You will have a table first. Yes, you will have table. There is no doubt in it. You will have a table. Here you will be having class. And here you will be having frequency. Cumulative frequency is not required as far as the mean is concerned. Like in class, you have taken the run is scored by the Sachin 0 to 10, 10 to 20, 20 to 30, maybe 30 to 40. How many times? 2, 3, 5, 4 and 1. So first try to decode what the problem indicates. May I know the observation has been taken place for how many number of matches? See, 0 to 10, 2 times, 10 to 20, 3 times, 20 to 30, 4 times, 30 to 40, 1 time. So how many number of observations we have taken? Number of observations are 2 plus 3, that's a 5 plus 4 plus 1, that's a 10. May I know in the first class how much run was scored by the Sachin? I exactly do not know whether it was 0, whether it was 1, whether it was 2, 3, 4, 5, 6, 7, 8, 9, 10. So what I will assume almost all 5 runs was scored 2 times. So what I will do, I would be calculating Fi into Xi. How the Xi used to be? Xi used to be the average between the lower class and the upper class divided by f2. Whether it's okay? Obviously okay. I assume the distribution is such that one time he might have scored one run. The second time he could have scored 9 runs. Put together 10 runs. So definitely the average would be 5 runs in a match. Yes. So here, may I know what would be Fi-Xi? Here it would become 5 plus 2, that's a 10. And here it would become 10 plus 20 divided by f2, that would be 15. 15 plus 3, that's a 45. And similarly 20 plus 30, that would be 50. 50 divided by f2, that's a 25. Into 4, that's a 100. And divided by, next is gonna be 30 plus 40, that's a 70 divided by f2, that's a 35. Plus of 1, that's a simply 35. May I know how will you calculate the average now? How would you calculate the average now? Total run scored divided by the total match played. May I know what's the total run is scored? Obviously 10 plus 45 plus 100 plus 35, you will add them together, which will become the total run is scored, which starts from 1 and goes till the last class, divided by the total number of match played. See, frequency itself indicates within this class Sachin have fallen 2 times, that means the 2 match have been last over here, 3 4 plus 1. And now if you say what would be the formula would be simply equals to Fi, where the I goes from 1 to n. So now it's your turn to get the average out of this. If you want, I can help you guys. It's gonna be 10 plus 45 plus 100 plus 35 plus 35. It's gonna be 190 somewhere. It's simply gonna be 190 divided by of 10. It's gonna be 19. It's gonna be 19. Yes? Yes, could you understand what I'm saying? Now one of the most important thing which I should be go into the great detail. See, instead the class you had xi, no? You had xi. Here xi was 5, here xi was 15, here xi was 25, here the xi was 35. Now in future, once we are dealing with the probability distribution and density, what will happen? Let's take a die is rolled. I assume, let's take a die is rolled and their outcomes are made to be random variables. In that case, may I know what are the possibilities you'll have? You'll have 1 over here, 2 over here, 3 over here, 4 over here, 5 over here, 6 over here. Yes. Rather having its frequency, now you will be having its probability. Tell me whether there is a much difference between frequency or probability. No. Frequency, that means how frequent that data is occurring. And what does it mean by the probability? How expected that data to be occur. Like if you have die as 1 or face as 1, and if you have a probability as 1 by 6, what does it mean of it? That means out of 6 number of times, 1 time you are getting face as 1. Similarly, if you have the face as 2 and its probability is 1 by 6, again you could understand out of 6 number of throw, 1 time you would be getting 2. What does it mean of it? That means this complete closed group data, or we can say this frequency distribution. Why it's called frequency distribution? Because we had a class and we had its corresponding frequency would get converted into the form of probability distribution. Here it was frequency distribution, and which will become now a probability distribution. Could you understand? Because the concept is more or less. Now here you were talking about the average. Average of what? Average of class. If class runs, average would come in terms of runs in per match. If class is marks, the average would come in terms of average marks scored in per examination. So that means whenever you calculate the mean, you get to know the mean of the class. But now inside the class you have a random variable. Like getting 1, 2, 3, 4, 5, 6, they all are random variables. So class, not class, basically xi is going to be replaced with the random variable. Frequency would be replaced with the probability. So end of the day, the result which would come would be mean, average, or expected value of. Instead this expected value of what? Random variable. Yes. And now I wanted to ask one thing. You guys would be interested in getting the average value of the random variable or not? Definitely you guys would be. I would show a few number of examples, then you will get to know about it. Is that part clear? So now let me go ahead with the next page. That means the formula was, see. The formula was, in case of frequency distribution, the formula was summation of Fi xi, where the I goes from 1 to the nth class divided by your summation of fi. Summation of fi. Again, it goes from 1 to n. 1 to n. But this was the case of frequency distribution when we were discussing the things over the statistics. But once you'll come into the probability distribution, see, the xi would be replaced with a random variable, that is for sure, and fi would be replaced with p, probability for the occurrence of that random variable. So instead the formula would become xi, you can write as xi, and here you can write the probability of the occurrence of that particular random variable. And at denominator you will be having sum of all possible values of pi. But once you go ahead with any practical problem where the probabilities are concerned, may I know if all of the probabilities got added, 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6, end of the day result is simply gonna be 1. So in future, whenever I would be interested in calculation of the expectation or expected value or the average value of the random variable, by default I would be using this formula. Where it goes from I is equals to 1 to the last digit, till the last information. Yes, could you figure it out what I'm saying? Now, even sometime you will be seeing even the probability distribution has also be distributed in the two parts. First is gonna be discrete random variable when the outcomes are finitely countable, and second used to be continuous random variable where the outcome used to be infinitely large. So in case we are going to deal with DRV, discrete random variable, this would be the process for getting expectation. And once we are dealing with the CRV where you can have an infinitely many number of possibilities, so discrete sum would get converted into the what? Continuous sum, which is integration and which starts from minus infinity and can go till plus infinity, and here it becomes x of f of x dx. You need not to worry about fx, you need not to worry about x, xi, pxi, everything would come into the picture once we will be going into the great detail. Yes, that means the average of the statistics have become the concept of expectation or the average of the random variable, where xi was a type of discrete random variable and x is a type of continuous random variable. Agreed? Anyways, this formula has to be by-hearted to each one of you. That's the first thing. Now tell me one more important thing, and from where we are going to derive few of the important formulas. See, I was concerned about taking the average of n number of datas which were x1, x2 and was going till xn. If the each and individual data got added by a, so it would become x plus a, x2 plus a, xn plus a. May I know what would be the new average? I cannot write each and everything. Why? Because my basic agenda to just discuss the concept of probability, distribution and density. So what is happening over here? That means if the each and individual data got added by a, the net average would be x1 plus x2 dash dash xn plus a n divided by of n. N goes out, the output would be just x bar plus of a. What does it mean of it? That means the individual data got added by a, at last the average would just get increased by a, and similarly that takes place if the individual data gets subtracted with a, like x1 minus a, x2 minus a goes till xn minus a. Yes, end of the day minus a n times can be brought it out, and hence minus a would come out, or you can say the new average would be minus a lesser than the older one. Not only that, if the each and individual data got multiplied with a, may I know what would be the new average? The new average would be a would come out, the new average would be a times of the older average. So now few of the important concept we can write. See, the concept of expectation have been brought it out from the concept of average, and hence whatever the concepts are true for average, that would be very same as expectation. Like expectation of x is being taken as, let's take it's the expectation of x, expectation of x in future. What I am going to do, let's take the each and individual random variable got added with b. So may I know what would be its new expected value or new mean? New mean would be simply equals to of older mean, that's the e of x, and separately you can add b together, as we have just seen, Similarly, if I take a next scenario, if each and individual random variable, or for the time being each and individual data got multiplied with a, may I know what would be the result out of this? It's simply a gets multiplied with e of x, Now take the last case, when we have ax along with b, definitely it would become a of ex plus of b. So the problem do come repeatedly from this properties. They are the important properties of the expectation, which is followed by either discrete random variable or the continuous random variable. Although you may not be able to appreciate what the CRV or DRV stands for, that part we are going to just discuss about. That part is just going to be discussed about. Is that part clear? Now come to the variance. See, you can write even a little bit point regarding that. See, write down, even the two data can have same mean. The two datas can have the same means. Two data can have the same mean. Same mean, but can have different variations from its mean. Can have the different variation from its mean. So first focus over the ungrouped data, and then we'll be focusing over the grouped data. Ungrouped data. Yes, ungrouped data. Let's take, we have got the n number of ungrouped data, and we are going to discuss about its variance. Let's take it's the x1, it goes to x2 and xn. What does it mean by the variance? I wanted to know the each and individual data, which starts from the first data goes till nth data, how they have been dispersed, how they have been distributed, how far they have been changed with respect to its mean. So what you will do, I am not worrying about x1, x2, x3 till xn. I am just worrying how the x1, x2 till xn they have been changing its value, or how they have been dispersed from its mean. So what I will do, see, try to understand. The first data, what I will do, I will take the subtraction. From its mean. See, sometime I get confused in it. First, I'll take the mean of this data. Let's take that mean of this data is x bar. What I will do, I will subtract x1 from x bar. Yes, what it says how x1 is deviated from x bar. Agreed. Thereafter, what I'll do, similarly with x2 also I'll follow the same thing. It's gonna be x2 how far it is dispersed from x bar, and similarly I would be doing with xn also. But and at last, if you really wants to know how the individual datas are dispersed, varying with respect to its mean, what you'll do, you'll just add them together, and at last you will divide with the number of observations. How many they are n. But there is one problem. What it is? See, maybe there is a large variation. Few variation where the datas are greater than the x bar, and few datas are where the datas are lesser than x bar. So what will happen? There could be a situation their result is somewhere +2, and here the result is somewhere -2. I cannot allow them to get cancel out, because either there is a deviation towards the plus side, either it's a deviation towards the Downside deviation is just deviation. So what you will do, either you can take a mod of it, and then you can add them together, and thereafter you can divide by n, or you can have another method. You just take square all of them, add them together, and at denominator you take n. And now if this data is large, that means the each and individual datas are very much dispersed, taking the reference of its mean. Yes, so from here onwards, keep in mind, it's called variance. So whenever we talk about the variance, how the variance is being defined, it's being defined as k is equals to of 1 till the nth data, and here we take xi minus of x bar. Keep in mind, even mean is also referred by mu. And here you will be taking square n divided by of n. Note, you can write higher the variance, high the inconsistency. If you want, I can give few number of examples, but again I am saying I am not going to spend much time on this. That is why I don't want to give much time on this. See. Let's take an data. It's a 50, 50, 50. May I know what would be the variance for this? It's your question number 1. And if I take the next data like 49, 50 and 51, what would be the variance of this data? You can see over well, there is no variation as such. If you will take the mean of 50, 50, 50, that itself is 0, and as such there is no variation. And once you will calculate its variance, you will get to know you had to take the discrete sum of, see, the first data, that's gonna be 50 minus x bar is also 50 square, plus of again 50 minus of 50 square, 0 square, divided by how many datas you have? 3. The variance of 50, 50, 50 is simply going to be 0. Similarly, if you take this situation, the situation is a bit different, but still the average is 50. So 49 minus of 50 whole square, plus of 50 minus of 50 whole square, plus of 51 minus of 50 whole square, divided by of 3. Yes. Could you understand what I am saying? So out of this becomes 0. Here it becomes minus 1 to the power of 2, that becomes 1. And 51 minus 50, that's a 1 square, that becomes 2. Put together here it's a 2 by 3. And you can see here the variance is large. And you can see very well here the variance is also large. So you can say the variance of Sehwag would be much higher than the variance of Rahul. Yes. Yes. Now what I am going to do, the same concept I am going to distribute, or I am going to extend towards the grouped data, and with the help of grouped data I will be extending the same concept over the probability distribution as well as density. So let me take this formula out. So may I know what was the formula over here? Discrete sum of x, what it was, just look it out. The same thing we will be writing over here, xi minus mu whole square divided by of n. So what I will do at next, let's take square of it. It becomes xi square plus of mu square minus of 2 times of xi into mu divided by of the total number of observations. Yes, do agree? So let's take square inside or discrete sum inside. So what it will become? Here it would become xi square divided by of n. Next, see, mu square is a constant component. So hence, if you take the sum, discrete sum from 1 to n, so by default it would become mu square into n divided by of n. Yes, obviously yes. And here 2 mu would be coming out, and here you would be left out with this. And may I know what it is? It's just mu, which is the average of the n number of datas. So end of the day, minus of mu square, minus of mu square. Now this was the conclusion for the ungrouped data. If you want to explore this data towards the group data, what will happen? What will happen? See, rather taking the average of xi, now you are interested in taking average of xi. Agreed? So I'll repeat it again. Rather focusing over taking the average of xi, now you are taking the average of xi square. So end of the day, if you want, you can simply write this as average of x square minus of, just a minute, there was a mistake, average of x square minus of square of average of x. Could you understand what I am saying? Yes. So here basically see, if it would have been just discrete sum of xi divided by n, then it could have been case of the average of x, but here we are taking a square and thereafter we are adding them together, dividing with n. That means we are going to take the average of xi square or x square, and similarly mu itself is the average of x, average of x. So end of the day, variance is written in so many ways. Is equals to this, and if you want to write this thing in terms of grouped data, the average of x square can be easily calculated. May I know what was the average of x? The average of x was xi fi divided by of summation of fi. That is, it was, no, but instead the xi now it would be xi square. Similarly, minus sign. If you come to this point, here we had to just focus over the average of x, that is fi xi divided by of summation of fi, which we also write n to the power of 2. Yes, agreed. Now, as I have already communicated, I would always be focused over the probability distribution as well as density. I would be calculating, maybe x is a discrete random variable. So instead the fi, it would be replaced with a p of x, and similarly it would be replaced with a p of x, and if you take the discrete sum of all of the possible possibilities, it becomes 1. So here it becomes p of xi minus of p of xi. Yes, and you will take the square of it. Agreed what I am saying? Obviously everybody should agree over here. And now even you can write this as the expected value of x square. Yes, see, average of x is nothing but the discrete sum of xi pxi, but instead the xi, here we have taken xi square. That means we are focusing over taking the average of xi, which is nothing but the expected value, and from here we can also write this as e of x whole square. Yes, and one more important thing, variance cannot be negative, would always be greater than equals to 0. Now the people may ask, why, sir? See, because you are taking the discrete sum of all positive value. At worst they could be 0. That is what I am saying. The variance of either you take ungrouped data, either you take a grouped data, either you take a probability distribution, it would always be greater than equals to 0, and hence one outcome we got out of this, e of x square, would be greater than equals to of. Yes, I know many of us would be afraid, sir, what are the big expressions, why unnecessarily you are writing them out? Now the turns goes out. Now all of the kachara part is getting over. We would be just focusing over the core concept. Let's take the next page and put it the heading as random variable. Put it the heading as random variable. Need not to worry, Priyes, need not to worry about it, dear. I have just designed each and everything. So it's going to be random variable. May I know what's the random variable? Or what's the random process? The random process is the process in which the outcome from any fair experiment is connected with the real value. Write it down. Random process is a process when the outcome is connected with real number. Real numbers. Yes. Let's take, I have taken a situation, and now you guys are straight away going to crack the problems, and now definitely you guys are going to enjoy now. Now in my time, when I was having the age of 10 years probably, in my state Chhattisgarh, we had the lottery system. The people here and there, they used to play lottery a lot. So I am going to design a problem based on random variable from that lottery system. See, I will say what was the basic culture. See, what was the basic culture? We used to purchase, not me basically, the people used to purchase a lottery. Lottery will have a number which starts from 0 goes till n, goes till 9. How many numbers they used to have? It's a 0, it's a 1, it's a 2, it's a 3, 4, 5, 6, 7, 8 and 9. 9 number they used to have. Yes. What they will do, they will purchase a card, they will purchase a lottery. In next day, the owner is going to decide out of 10 number of digit which is going to be winner. Anyways, so far, whether they are random variable, no sir, they are just outcome. So far, they are just outcome. Do not get confused with this. They are just outcome. Yes sir. Okay, they are just outcome. Now I am connecting the outcome with the real numbers. Like, how will I connect this from real number? Waiting for problem. Okay. How will I connect with the real number? I'll let you know. The cost of each and individual lottery was 11 rupees. How much it was? 11 rupees. And when a person win the game, he gets return of 100 rupees. That means you are going to purchase a lottery ticket with the amount of 11 rupees. And if you won, then you would be getting 100 rupees from the owner. So you will get to know, I have taken a lottery ticket. In next day, the winner was the number 3. So may I know what would be the real number which would get connected with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this real numbers can be, or this random variable can be fabricated from the seller side, or it can be fabricated from the user side. If I design this problem from the seller side, see, try to understand, from the seller side, the person who have purchased the lottery having digit is equals to 0. May I know the seller how much money he has earned? He has earned 11 rupees, and that is why it has been taken plus. Why he has earned 11 rupees? See, he has just sold a piece of paper for 11 rupees. The person have purchased it, but he did not give any amount for that piece of paper. That was just garbage, because the winner was 3. Yes. Similarly, in 1 also he will be getting 11 rupees. For 4 also he will be getting 11 rupees. Everywhere he would be getting 11 rupees. May I know for 3 whether he is winning or losing? I want the output in comment. And how much amount he is winning or how much amount he is losing. I want the output on the chat box. For 3, how much amount whether he is winning or how much amount whether he is losing. I want the output over the chat box. How much amount he is winning or losing. Whether he is losing, if it is losing, definitely I will be taking the sign as minus. If the person is winning, I would be taking sign as plus, but still I want the amount also. I want the comment from everyone, no? So you guys should not sleep. If you guys are connecting with my video, at least with reply with some requirement. Tell me, what would be the random variable over here? What would be the random variable over here? What would be the random variable over here? Tell me. How much money he is going to lose, the owner? how much money he is going to lose. See. Try to understand. Already he has taken 11 rupees from the person. And now he is returning 100 rupees. So he is getting the loss of only and only 89 rupees. And now why the minus sign is come in? Because he is losing. And the complete probability distribution was designed from the side of seller. And similarly, if we talk about the probability of the occurrence of the individual trial, obviously the 0 could have won 1 out of 10 number of times, and it goes till 1 out of 10 number of times. Yes, and my expectation, I wanted to know on average the seller is earning how much. On average, in per game, seller is earning how much. That would be your area of concern. Why? Because if I have a company, I might be losing something, I might be gaining something. My gain and lose for the time being would not be my area of concern. My area of concern would be on average in per match how much I am earning or how much I am losing. Yes, so here it becomes the formula you can recall. The formula is simply equals to of xi p of xi, where the I goes from the first data till the 10th data. So you have to multiply them together. Yes. So here it becomes 11 will get multiplied with 10. So may I know how many times the 11 will get multiplied with 10? So here it becomes 11 divided by of 10. 11 divided by of 10 into 9. And similarly 89 with a minus sign would get multiplied with 1 upon 10. Yes, and if you will take result out of this, is going to be 99 minus of 89 divided by of 10, and that is nothing but plus is the important thing, plus 1. What does it mean of it? That means the seller is winning on average plus 1 rupees in per match. Yes. What does it mean of it? That means the person who is purchasing the lotteries, end of the day they are going to lose 1 rupee per lottery ticket. That is what I am saying. Even the lottery ticket also follows the concept of probability, and even you will try to understand whether you are losing or whether you are winning from the lottery. How will you know? Because it's such a complex data collection it is. Until and unless you are not analyzing the data and you are not concluding something a single value, you would not be able to know anything. And you could know only one thing. Yes sir, on average. You got the average of what? You got the average of random variable. And may I know what is that random variable? The random variable is nothing but the amount the seller is winning, and that is why wherever he is winning or wherever he is gaining, I am taking the value as plus, and wherever he is losing, I am taking the value as minus. That means the seller is going to win on average 1 rupee in per piece of lottery. And still the people are playing and they are saying, I have won, I have lost, I have won, I have lost. No, it's not happening. Yes. So let me do one thing. Let me take one or two number of problems. See, this is my first question. Gate Electronics year of 2015. The problem was framed by IIT Kanpur. I want the answer for this particular question. Yes. A fair die with the faces 1, 2, 3, 4, 5, 6 is thrown repeatedly till 3 is observed for the first time. Let x denotes the number of time the die is thrown. The expected value of x is. the expected value of x is. The expected value of x is a fair die with faces 1, 2, 3, 4, 5 is thrown repeatedly till 3 is observed for the first time. Let x denotes the number of times the die is to be thrown. The expected value of x is. That goes to your first problem. That goes to the first problem. How will you get to know about it? How will you get to know about it? Just try to understand. See, that means you must have a clear-cut idea. You are going to calculate the mean value of x. That means the x is a random variable. May I know what is a random variable? The outcome should get connected with a real number. It has been clearly given where it is. Let x be denoted as the number of times the die has to be thrown. The number of times the die has to be thrown. So now you had to have a clear-cut idea how to go ahead with this problem. See, you have a random variable x. You have a random variable x. For getting thrown repeatedly till 3 is observed first time. See, now x is 1. X is 1. What does it mean of it? That means in first throw itself, 1 is what? The number of times the throw is required to get the 3 first time. If x is 1, that means in the first throw itself you could get the outcome as 3. And now if you talk about the probability for getting 3 in the first throw itself is simply gonna be 1 upon 6. 1 upon 6, obviously. Now go to the next condition. Go to the next condition. When you will be requiring the 2 throw for getting 3 first time. In that case, the random variable would become 2. And here it would become, if the first throw was anything apart from 3, that is 5 by 6. And the second throw had 1 by 6. Second throw had 1 by 6. Yes. And similarly, you will be having the third case when you need to throw 3 number of times. And in 3 number of times, the last time you experience 3 first time. How it's possible? It's possible if 5 by 6, 5 by 6 and 1 by 6 gates multiplied together, and that process would keep on going. Yes, obviously yes. So end of the day, what you had to calculate? You had to calculate the expected value of x. How the expected value of x is being defined? We have already seen about it, no? It's nothing but xi, p of xi, where the I goes from the first data till the last data. And how many datas we have? We have the infinite number of datas. So end of the day is gonna be 1 gets multiplied with 1 by 6. It would be 1 by 6 plus 2 times of 1 by 6 into 5 by 6. Third time it's a 3 into 5 by 6 going to be in 2 times, and again it's gonna be 1 by 6. Its complete sum, infinite number of time, would lead the expected value. May I know what would be the value out of this? That has to be calculated by you guys. I have just calculated this value, and definitely you would be getting the answer out of this. Yes, it's the AGP series. Arithmetic geometric progression. So what you will do, you will make or you will subtract the e of x with the 5 by 6 times of ex, and thereafter this series would be a perfect example of GP series, and from there you will get to know the expected value is 6. That means on average, on average 6 number of times you had to throw your dice for getting 3 first time. Probably if you have thrown in first time itself 6 would have come. Now if you keep throwing, maybe in 12 number of times the 6 have come. So if you take the average of the number of times the throw have come and first time the 3 have appeared, you will see that on average just 6 number of times you had to throw your dice for getting 3 first. Is that part clear? If it is clear, just write clear. So at least I'll get to know the things are clear to all of us. Yes. Now goes to the second question. Now get the answer for this. Now get the answer for this. That's tell me what would be the answer for this particular question. See, let x be the random variable which is uniformly chosen from the set of positive odd numbers. That means now the random variable itself is the positive odd number which is lesser than 100. That means which will start from 1 will go till 99. See, until and unless you are not very fixed about the random variable, you would not be able to address your problem well. So you had to be clarity on over the random variable. So the random variable starts from 1, 2 and would get till 99. Yes. Let x be a random variable which is uniformly chosen from the set of a positive odd number less than 100. Now. If you have how many datas? If you start from 1 goes to 3, then goes to 5 and ends at 99. How many number of datas you'll have? 50 number of datas you have. Selection of number as 1. What would be the probability? That would be the probability for the random variable x to be 1. X to be 1. So you can simply write 1 out of 50, 1 out of 50 and 1 out of 50. Yes, you guys are able to understand what the random variable stands for. The random variable, a practical outcome is getting connected with a certain real number. Here what have been said, the number value itself has been assumed as a random variable. That means the odd numbers which starts from 1 goes till 99, those all numbers are itself my random variables. Even sometime they may say double of the number. In that case the 1 would become 2, 3 would become 6. Yes, do not get confused. It was my outcome as well as the random variable because it has been clearly given on the problem. So now I am interested in getting expected value of the random variable. How will we calculate? It's simply gonna be multiplication this way, between this plus this plus this. So everywhere the 50 would come at denominator. Obviously, let it be. No issue. And at numerator we have got a AP series. Yes, sir. Obviously, yes, sir. Now you can use the formula. What's the formula you used to have? N divided by f2, sum of n number of AP series, n divided by f2, 2a, or you can simply this write as a plus L divided by of 50 also. If you know the first term and the last term, that also you can do. So here it becomes n is how much? 50. This 50 and this 50 goes off. The a is how much? 1. L is nothing but 99 divided by f2. So the answer is gonna be 50. What does it mean of it? That means on average in each trial I am picking the number which is 50. That's a different thing. First time you might be getting 1, second time you might be getting 99, third time you might be getting 3, fourth time you might be getting 97. But on average, if you keep on doing the same practice again and again, end of the day you will be land up with the situation that on average 50 has been brought out. Is the part clear to all of us? So probably it must be clear to all of us. Now let me go back to my working board. Yes. Now let me bifurcate random variable first. And then we'll try to smash few more number of problems. Yes. Now the random variables can be bifurcated in the two parts. First is gonna be DRV, discrete random variable, and the second is gonna be kind of continuous random variable. When we use DRV, when we choose CRV, that solely depends on the practical problems. Like if you have infinitely many number of, or here if you have finite number of observation. Like like the two problems which we have taken so far. Like in case of lotteries, how many number of observations you can have? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Similarly, in case of the second problem, you can have the output or the random variables which starts from 1, 2, 1, 3, 5, 7, 9 and thereafter goes till 99. If you have finite number of observations or finite numbers which can be attained by the random variable, the problem comes with a DRV. That means all three problems which we have taken so far, they were the problem of DRV. If you want, we can take an example. The example could be like rolling a die. Rolling a die could be a perfect example of DRV. Could be a perfect example of DRV. Is that part clear? Similarly, if we talk about the CRV, when we have CRV, when you have infinitely many number of observation, infinite observation. Now, thing would come in a mind. Can we have an example? Obviously, see. If temperature in Korba, the class from where I am delivering the lectures is Korba. If the temperature within the Korba is being taken as random variable, may I know how much or how many different temperature observations you can have in Korba? Let's take the temperature between the Korba is somewhere falls maybe 10 degrees centigrade to 45 degrees centigrade. So may I know in between 10 to 45 degrees centigrade how many number of temperature observations you have? Infinite. Why? After 10 it could be 10.00001, 0002, even you can be 0.000001. So in between 10 to 45, how many number of observations you have? Infinitely many. So if you deal with like temperature, maybe flow, maybe rain, is that part clear? That's the infinitely huge. And there we discuss about the continuous random variable like rainfall, like temperature. Yes, like rainfall, like temperature. Now, in DRV we used to have a probability function as a probability mass function. Keep in mind. Probability mass function, whereas in CRV we used to have probability function as a probability density function. Yes, probability mass function I would be referring it by P of xi or P of xj, and whereas probability density function would be referred by f of x. Yes. Similarly, cumulative probability function. In case of cumulative probability mass function, I would be writing it f of xj. And similarly, in case of cumulative probability density function, I write this as capital F of x. So few of the important properties you can write. The first important property, if you take the discrete sum of all of the probability mass function which starts from 1 till the last one. In few of the cases, the last event could be second event, third event, fourth event. So in general, I have taken till infinite event, it would always be 1. Because you are cumulative all of the possible probability mass function. Not only that, P of xj would always be in between 0 to 1. Never it will go beyond 1, never it will come lower than 0. Similarly, if you wanted to calculate the probability mass function at any observation, let's take at xj, you can easily get that out by calculating f of xj minus of f of xj minus of 1. Yes or no? Obviously yes. Like in case of probability, in case of cumulative distribution, you could have seen, if you are in certain class and if you wanted to know what's the frequency on that, you take its cumulative frequency and you just subtract with the earlier cumulative frequency, you will get to know about the probability and for the time being frequency at that class. Frequency at that class. Obviously yes. Yes. If I come over here, the area under the curve for any well-defined probability density function would always be 1. Would always be 1. Agreed? Now, f of x would always be greater than equals to of 0. Yes, there is no limitation that it can't go beyond 1. It can go beyond 1. If I will have time, I would let you know why it's happening. Why it's happening. Now, if you want f, or which is nothing but the cumulative probability function at x is equals to of a, then you had to integrate the value which starts from minus infinity goes till a, f of x dx, f of x dx, f of x dx. Is that part clear? So f of x is equals to a is simply gonna be integration from x is equals to minus infinity to a f of x dx. And at any moment of time, if you want to extract the probability density function from the cumulative probability density function, you can just take the differentiation at that point. Differentiation at that point. Differentiation at that point. At that point. Differentiation at that point. Could you understand what I'm trying to say? Could you understand what I'm trying to say? So these formulas are very important formulas, and we guys should able to recall this formula, or should we be able to by heart these formulas? We should be able to by heart these formulas. And now I would say, because I am not in mood to explain why, from where those expressions have come, because everything have got its own basis. Everything have got its own basis. I would suggest to each and everyone, whenever I say just reply, please reply, which gives us a immense amount of energy and which makes us to teach more and more. But anyways, for the time being, I would not be going beyond this. I would not be going beyond this. Yes. Let me take few understandings. Let me take few understandings. I have taken few number of questions. Let me go ahead with the few number of questions. Yes. For a random variable x following a probability density function px shown in figure, the mean and variance are respectively. Mean and variance are respectively. How will you solve this sort of problem? At very first, if you want, you can check it out whether this probability density function is a genuine probability density function or not. You can check it out. How? We know for a genuine probability density function, area under the curve of PDF has to be equals to of 1. Has to be equals to of 1. As far as the P of x or f of x is concerned, it is non-zero within the range of -1 to 3. So if you will take the integration by parts, you had to integrate from -1 to 3, and that too for 1 upon 4 dx. May I know what it is? In calculus, we have studied this thing in the great detail. It's the area under the curve from -1 to 3. The upper lobe would be taken as positive, and here you can see this width is nothing but 4, and this height is nothing but 1 upon 4. So end of the day, the gain or the value which you will be getting, it's 1. So obviously it could be qualified as a probability density function. Probability density function. Anyways, it has been clearly given, so you need not to worry about it. You need not to worry about it. But next, what are the datas are being asked? What are the datas are being asked? Has been asked for getting expectation. Before going into the detailed analysis, first tell me whether it's a continuous random variable or it's a discrete random variable. See, x is a random variable over here. So may I know this problem is from continuous random variable, whether this problem is from discrete random variable? Obviously this problem is from continuous random variable. Why? If you take the any data in between -1 to 3, obviously, which would be the value of x, that's infinitely many. From -1 you can go to -0.999999, so on and so forth, till -1 to 3, infinitely many number of observations you have. So it's a problem of CRV. So expectation would be used for continuous random variable. May I know what was the expectation? The expectation was the integration from -infinity till +infinity, and here the f of x would come, into x times of dx. No, you should not forget this x. You should not forget this x. But as far as the f of x is concerned, it is a non-zero quantity only in between -1 to 3. So here it would become, -1 to 3. It's the x, and f of x is nothing but 1 by 4. 1 by 4 can be taken as common, and here it becomes only this. It becomes 1 upon 4, the integration from -1 to 3, and here it becomes x. So here it is nothing but 1 upon 4, and it becomes x square divided by 2. The 2 would come over here, x square. What would be the x square? First you will feed 3, that would become 9, minus of 1, that would become 1. So tell me how much the expected value we have got it. Here 9 minus 1, that's the 8 divided by of 8, the value is simply going to be 1. Let me check it out how much the answer is we are getting. Obviously the expected value is 1. Yes, the expected value is 1. Either you can have B as answer, either you can have C as answer. Yes. Now we'll be going ahead with the variance. See. When you had to calculate the expectation as well as variance, use the formula. What was the formula? Once you are calculating the variance of any random variable x, it is simply equals to of expected value of x square minus of expected value of x whole square. See, unnecessarily, why will you waste this output? Because this output is nothing but the expected of x, which could be straight away plugged it into the problem and get the answer. Yes. Now we need to get the expected value of x. See, the expected value of, where it is, the expected value of x was, where it is, just a minute, the expected value of x was integration from -infinity to infinity fx x dx. Now the expected value of x square would become f of x square dx. I would repeat, the expected value of x square would become f of x square. Whatever the value comes, you had to feed over the e of x square, and the e of x to the power of 2 is already known to me. So let me do one thing, only a bit change I would be introducing. This is already known to be 1 square, just a minute, which is already known to be 1 square, which is equals to of 1 alone, and now expected value of x square. So I would suggest whenever you have at least expectation of x, use that value for getting the variance. Okay, so here you had to integrate from -1 to 3, f of x is known to me, which is 1 by 4 x square dx, and you will get the data out of this. How much value we are getting? 1 and 2 by 3. Yes, the C is the perfect answer. Let me check it out whether we are getting same or not. For the question number 3, I had the answer key. Yes. 3, whether it's B or C, check it out. Check it out whether it is coming B or C. I want the answer from C, no? Because I don't have any answer. If you want, I can check it out. Okay, let me check it out. So here 1 by 4 comes out. And here it would become x cube divided by of 3. The 3 will also come out. X cube. First it would become 3 to the power of 3. Then it would become 1 to the power of 3. Yes. So here how much it's coming? Tell me. How much it's coming? Tell me. C, no? C, let me. Tell me. C it's coming probably. C it's coming. Yes. Check it out how much it's coming. So probably this part must be clear to all of us. This data has to be fed over here, and thereafter it has to get subtracted with 1. So probably it's gonna be 12. Okay. 27 plus 1, that's the 28. Let me put it over here. 28 divided by of 12 minus of 1. It would become 28 minus of 12 divided by of 12 divided by of 12. So here it would become 6, 12, 4 4 ja, 4 3 ja, 4 3 ja. Yes, the answer is B. The answer which we have got it, all are wrong. CO Prasad, it's not C, the answer is B. Because I can see over my answer key, the value is going to be 4 by 3. This data has to be put it into this, and then only you have to get this answer. You have to get this answer. So anyways, the best most answer is going to be option B. So in future, see, most of the time I have seen the problem comes to calculate expectation separately, variance separately, but as far as this problem is concerned, they have asked to calculate both of them together, and you can easily get the value out of this. If it is clear, just write clear. I will be taking the next question. Yes. Probability density function of a random variable x is given by f of x is equals to 0.25. If it's in between 1 to 5, 0 otherwise, I want to get the probability when the x is less than equals to a 4. See, that means you are interested in calculation of the probability for having the random variable less than equals to a 4. See, just try to understand. If random variable moves from minus infinity to plus infinity, what used to be its probability? The probability used to be 1. But now, here precisely we want to calculate the probability that the value of random variable is less than equals to a 4. May I know what it would be? The integration, the lowest limit of the random variable can start from minus infinity and can go till plus 4. Why? Because I need to calculate the probability till plus 4, fx dx, yes, fx dx. But what is happening over here? You cannot go till minus infinity, because from 1 onwards or lesser than 1 onwards, the f of x is 0. So virtually you will be taking the situation. It starts from 1. And goes till 4. And in between 1 to 4, may I know what is the worth of f of x? It's just simply equals to of 0.25 dx. 0.25 dx. And end of the day, if you get the result out of this, is going to be 0.25, 4 minus 1, and 0.25 is getting multiplied with 3. The result would be 0.75. Yes, result would be 0.75. And even if you want, you can calculate the variance also. Yes. The answer is gonna be A. Let me take the next question. Probability density function, differential function p of x of a random variable x is shown below. The value of alpha is equals to, keep in mind, for a qualified probability density function, the area under the curve of the given PDF may be minus infinity till plus infinity has to be 1. There should not be any boundaries in it. That has to be. Again, I am saying in crash course, I cannot go into the great detail. Otherwise, probability distribution density itself, it takes around 15 hours to get completed. Really, I am saying, which we are going to cover within 2 hours. But anyways, as far as the concept of crash course is concerned, we are going to focus more over, you can get the question and you can smash those questions very well. Otherwise, I need to take around 12 to 15 hours to just cover the concept of this. No. Try to understand. What would be the worth of it? Area under the curve, but you can see very well, before A and after A plus C, the PDF is 0. That means the area under the curve has to be taken from A to A plus C of f of x dx. The value has to get compared with 0. Yes. Now you can do one thing. You can convert this triangle into the two right angle triangle. This is the first right angle triangle and this is the second right angle triangle. And we know very well the area under the right angle triangle. And you can calculate easily. if you talk about this area is going to be half times of height. Height is simply alpha, and a plus b minus of a, that would be simply b. That would be simply b. Yes, plus half times of, again if you talk about the area under this triangle, it would be simply equals to alpha, and here a plus c minus of a minus of b. So may I know what would be the result? It is gonna be c minus b, and thereafter the result has to be equals to 1. Yes, could you understand what I am saying? The half times of alpha, now which is getting multiplied with b, plus half times of alpha, which is getting multiplied with a plus c minus of a minus of b. So a and a goes off, and only the c minus b would be left out. So what I'll do, first half you can shift towards right hand side. So here it becomes alpha, beta is also common, plus of c minus of b is also common. Yes, and here it's gonna be 2, b and b goes out. The answer is gonna be 2 divided by of c. If alpha is kept 2 divided by of c, the area under the curve for the given PDF would become simply equals to of 1, and hence you got to know that it is a genuine PDF. Yes. So I would suggest one more thing. Try to cover the normal distribution by yourself. At least one formula you can remember. And from that formula you can calculate many of the things. See, if you talk about the normal distribution, its a valid PDF used to be 1 upon sigma root over 2 pi exponent of 1 upon 2 with a minus sign x minus mu divided by of sigma whole square, where the x goes from minus infinity till plus infinity, where mu are the mean, sigma is the variance. And if you'll try to draw this curve out, yes, see, the magnitude is going to be decided by this factor. Yes, and even try to understand this curve, or I can say the normal distribution curve would be symmetrical to what would be decided by mu. Just try to understand in this way. Then see, try to understand. The mu, or I can say the normal distribution would be symmetrical to always x is equals to of mu axis. So even once you'll see normal distribution, you'll get to know what's the value of mu. May I know the PDF is symmetrical to what? The PDF is symmetrical to the x-axis, and x-axis is also written as x is equals to 0 axis. So by seeing this problem, at least you'll get to know the value of mu, or the value of expectation for this given normal distribution is simply equals to 0. Now may I know what is its magnitude? See. What would be the maximum magnitude? The maximum magnitude will x becomes mu. Once the x becomes mu, it will become 0. E to the power of 0 will become 1. The maximum magnitude is going to be 1 upon sigma root over 2 pi. It's going to be 1 upon sigma root over 2 pi. Yes. 1 upon sigma root over 2 pi. May I know where the sigma is higher? See. The peak and sigma is inversely proportional. I repeat. Peak and sigma are the inversely proportional. Yes. Here peak is lesser, and hence sigma will be more. Let's take it's a sigma 3. Here the peak is moderate, the sigma would be moderate, and here the peak is highest, the sigma would be least. Sigma would be least. Yes. So you can say in this way, sigma 3 is greater than sigma 2 is greater than sigma 1. Sigma 1. Yes. Sigma 3 is greater than sigma 2 is greater than sigma 1. Sigma 1. Yes. And now what is happening over here? If the curve got shifted, now let's take the curve is sort of this. Now it has been taken the reference of, let's take x is equals to of 1 and the curve is sort of this. So by seeing how the curve is symmetrical about which axis, you will get to know the value of mu. And now the curve is symmetrical to x is equals to 1. You can easily say the mu is equals to 1. Mu is equals to 1. And one of the most important part regarding this, it is also a well qualified PDF. So once you get the area under the curve of this value from minus infinity till plus infinity, then you'll get to know, irrespective of mu, irrespective of sigma, always its integration would be 1. Now it would be your homework. Using gamma integration. Using gamma integration, you had to get this thing to be satisfied. Yes, irrespective of the value of sigma and gamma, the area under the curve or the integration of this complex function would always be 1. Yes. I would repeat once again, the sigma is nothing but, what is sigma over here? Sigma is nothing but the standard deviation, keep in mind. Somewhere, yeah, sigma is the standard deviation. Nobody should get confused. Sigma square is the variance and sigma is just a standard deviation. Yes. So more or less I could communicate a bit about the random variable, random process. So let me consolidate the things once again. But anyways, I have said the completing this is not that possible within that short span of time, but you will have a fair idea. See what I have saying. I was saying the first I started with the statistics. Why in statistics we were collecting the data, and after the collection we were analyzing the data. Even in probability distribution and density also we have collection of data, like a die is rolled 1, 2, 3, 4, 5, 6. What are they? They are collection of the data only. But what we had once collecting the data, we were seeing or we were watching what would be the output from its analysis. The same thing is done with the probability distribution as well as densities. Yes. The two datas we were worrying most of the time. On average data and how the datas are varying taking the reference of its mean. First we started with the frequency distribution. The same formula was used in case of DRV and the same formula was used for the CRV. In case of frequency distribution and DRV, only one difference was there. Instead the f of x, we used p of x. And once we talk about the complete sum of f of x, there it was capital N, but here it is 1. So the formula got changed little a bit. But once we talk about the CRV, rather taking discrete sum, we need to take the continuous sum. So the discrete sum of sigma got changed to the integration of the complete sum. And now the range has to be from minus infinity to plus infinity. Like if p of xj to be a qualified probability mass function, its complete sum has to be 1. Because adding all probability together has to be equals to 1. And similarly in case of continuous random variable, the probability lies in terms of area. So that is why I am saying the area under the curve from minus infinity to infinity, if we have f of x, has to be 1. Now we talked about the cumulative probability mass function. If you want to know the cumulative probability mass function till observation x is equals to 2, so you had to add the probability at x1 as well as x2. So what does it mean of it? That means f of x2 is equals to of p of x1 plus of p of x2. That is what it happened. But if we talk about cumulative probability density function at a certain point x is equals to of a, that means you had to cumulate all of the area which is keep coming from infinity till point x is equals to a. So you can say capital F within the bracket x is equals to a is equals to of integration from minus infinity to a f of x dx. That's it. Now f of xj, p of xj can't be negative. It can't go beyond 1. Why? Because P of xj is nothing but the probability itself. So obviously it would be always in between 0 to 1. But as far as f of x is concerned, no, small f of x is concerned, it's a probability density. It's not the complete probability. Just keep this thing in your mind. So f of x, small f of x would always be greater than or equals to of 0. But yes, it can go even greater than 1. It can go even greater than 1. Here also we had one more thing. Nowhere in continuous random variable you would be willing to calculate, nowhere you would be willing to calculate the probability that the temperature x is 42.2. This value would be simply 0. Why? Because you have got the infinite number of event. Out of infinite number of event, what's the probability for the event 42.2? That becomes 0. That is why in case of continuous random variable, we do not talk about the probability of the occurrence of a certain event. We talk about the probability of the occurrence of certain range. So I can say what is the probability that the temperature in Korba is 42.2. I would say 0. But if somebody say what's the probability for temperature in Korba to be in between 30 to 40. So what I'll do, I'll take the integration of f of x dx from 30 to 40 and I will get the answer out of this. And most of the time the problem do come, the problem do come in that way that the f of x would be given to you and they will be asking few of the unknowns stating that the given f of x is a qualified PDF. What you have to use the standard formula or standard concept which has been applied over the PDF. The area under the curve inside the qualified PDF should always be 1. Yes. So more or less the concept is over. So probably tomorrow we are going to discuss about the brief description of vector calculus. So till then, bye-bye, take care, and most importantly, keep reading and join my Telegram, whatever the type of doubts you guys are having, because I cannot cover each and everything over the crash course. If you have still doubt which have been left out, which have come in previous year GATE examination, you can put it over there. I'll try to get the solution for that. Is that part clear? Thank you very much.